The Monolithic Dome, a paradigm shift in construction technology. Monolithic domes are built for homes, schools, sports facilities, churches, bulk storages, and more. Hundreds of monolithic domes have been built all over the globe. This construction process was invented in 1975 by David B. South and his brothers, Barry and Randy.
While I was in high school, I learned about the geodesic dome. It was being promoted by Buckminster Fuller. The geodesic dome held the promise of covering more space with less material than any other structure. That fascinated me. But I worked on the geodesics for many years trying to make the promise work out because I wanted to build big domes. And it finally came to me after a lot of work in the potato storage industry that I could build a dome by inflating an airform and spraying it from the inside. That defied all tradition.
All monolithic domes, regardless of size or design, are built using essentially the same construction process. The monolithic dome starts as a concrete ring beam foundation, reinforced with steel rebar, giving the dome the structural integrity needed to withstand fire and disasters. Vertical steel bars embedded in the ring are later attached to the steel reinforcing of the dome itself. Small domes may use an integrated floor ring foundation. Otherwise, the floor is poured after completion of the dome. A custom-designed airform made from a PVC-coated fabric is attached to the ring beam. It is inflated with fans to the specified pressure, usually 2 inches of water column. The airform assumes the shape of the structure. Fans maintain the pressure on the airform and continue to run throughout the construction of the dome shell. Approximately 3 inches of polyurethane foam, considered by many to be the world's best insulation, is sprayed onto the interior of the airform. Special rebar hangers are embedded into the foam, which provide the base for attaching the steel reinforcing bar. Rebar is attached to the foam in a specially engineered horizontal and vertical pattern. The size and amount of rebar used depends upon the purpose and size of the structure. For example, large domes require large bars with small spacing, while small domes require small bars at larger spacing. Next, shotcrete, a super strong spray mix of concrete, is sprayed onto the interior surface of the dome. The steel rebar is embedded in the concrete. Thickness of the concrete depends on the size and purpose of the building. An average of 3 inches for a home to 2 feet thick for a heavy-duty bulk storage facility. Once the concrete is set, the fans are shut off and the monolithic dome shell is complete. The airform is left on the dome as a single-ply roofing membrane, which acts as a vapor barrier and protects the foam from harsh ultraviolet rays. As an option over the airform, the dome can be coated using a variety of different coatings. As each step in the construction process is completed, the dome gets stronger. Its full strength is realized after all the concrete is set. Monolithic domes are strong, energy efficient, cost-effective, and permanent. All monolithic domes, regardless of their shape, size, or purpose, share common benefits. Monolithic domes can be built to meet the Federal Emergency Management Agency's definition of a structure that provides near absolute protection, and therefore can be used as shelters when disaster strikes. Italy High School in Italy, Texas, has a tornado shelter disguised as a gymnasium. City officials have keys to the gymnasium so they can open the facility for anyone seeking shelter during a tornado warning. From Friday, September 29th to Sunday, October 1st, 1999, Hurricane Keith, a Force 5 hurricane with winds up to 135 miles per hour, raged over Ambergris Key off the coast of Belize in the Caribbean Sea. These 2 monolithic domes endured and survived Hurricane Keith's fury virtually unscathed. Island residents took refuge in the domes while property around them was decimated. Security is just one reason many people are choosing monolithic domes. Energy efficiency is another. When concrete and foam in a monolithic dome work together, has a large thermal battery which maintains even interior temperatures. It therefore takes 50 to 75% less energy to heat and cool monolithic domes compared to similar-sized conventional structures. In 1984, Maranatha Church in Mont Belvieu, Texas, built a 34,000 square foot dome sanctuary and has since reported significant energy savings. During 1998, Pastor Ronnie Trice said that the Maranatha Temple's heating and cooling cost averaged about $1,500 per month, which proved to be $8,500 per month less than a similar-sized nearby conventional church. Over the lifetime of a monolithic dome, energy efficiency amounts to huge savings, generally the value of the dome over 20 years. Savings can also be realized in construction, maintenance, and insurance costs. Payson School District in Payson, Arizona built a 200-foot diameter gymnasium in 1997, which cost $2.9 million, far less than the $6 million the nearby community of White River, Arizona spent for a comparable traditional facility, making the monolithic dome approximately 50% less to construct than the conventional gym. Because monolithic domes cannot be destroyed by fire, tornado, hurricane, earthquake, termites, or mold, they cost less to insure. In addition, considerable savings can be generated because of the dome's strength. Conveyors, large scoreboards, machinery, heavy lighting fixtures, and other equipment can be safely hung from the dome shell without additional internal structural support. The Pantheon in Rome, Italy is the monolithic dome's oldest cousin. Built in 126 AD, its dome measures 143 foot in diameter. For centuries, it was the largest single-span dome in the world. It is still in use today. Over the years, as needs change, a monolithic dome may need remodeling and a coat of paint, but not replacement. With minimal maintenance, the lifetime of a monolithic dome is measured in centuries. The monolithic dome is disaster-resistant, energy-efficient, cost-effective, and permanent. We often see portrayals of the future where the architecture is primarily domes. The future is now. The monolithic dome is truly tomorrow's building available today.